JSON data structure is an excellent one for storing and passing data in between servers. However, did you ever find yourself fighting with the JSON structure with its hierarchical nature in order to find and locate the data that you actually need if it's nested inside? Well, Edgar Code has been through this 50 years ago, and he has then came up with a relational model of databases. Before Edgar Code, there was no an actual relational database model. The models that existed prior to 1970 were the hierarchical and the network models. In both these models, you faced the same problems that you face usually with a JSON structure, and due to its hierarchical nature, you navigate through the data, try to find the structure that you need. So Edgar thought about it, and he brought the concept of relations from mathematics into databases, and he presented it on the 1970s with his paper named A Relational Model of Data for Large Shared Data Banks. In this paper, he introduced the relational data model, which says we should not care, the programmer should not care about the structure of the data, be it navigational, be it hierarchical. The programmer does not care. The programmer cares about the true nature of the data, and the true nature of the data is a relational one. This was a radical new thought about how to organize databases. This opposed the existing schools of thoughts, which were the hierarchical and the network model. In both these models, you structure your data in a navigational one, where you needed to get into, let's say, if you get into the comments of the blog, then you first go to the blog, then to the blog post, and then to substructure a specific blog post, and then to the substructure of the comments, a whole document. But this created a lot of problems for programmers. Actually, the schools of thought of the network and the hierarchical model called programmers data navigations programmers, or the programmer as a navigator. This was an actual name of a speech made by Charles Beckman. So Code saw this inflexibility as a symptom of a large problem. He thought we are not abstracting right how we model data. And if we abstract better this modeling of the data, we could come up with a structure which would be both more generic and would allow us to manipulate and to query the data in a better way. And we can pretty much say he was right, because 50 years from then, from when he presented his thought, SQL still rules the world of data query. He was pretty much right. Basically, what he wanted to do is to ignore the implementation structure of the data, which was a tree or a map of objects. He wanted to ignore this and to treat the data in a more abstract way, in the relational one. This is called by Edgar Code, data independence, separating the actual representation of the data from how you query and use it. You ignore any artificial structure imposed on the data like trees. You just take the data as is, as more theoretical concept. The specific point of failure that he detected in this representation of data was when you had this hierarchical structure, you actually had sub-objects. So when you have a blog post and then you have the comments as sub-objects, this is the problem. This is the thing that you need to, in relational terms, normalize. And normalize does not mean a pointer from the blog post into the comments, because a pointer brings you again into the concept of navigation and of trees, where you point from one data structure into another. By normalization, he merely means in his paper storing the raw values. As long as you have the raw values for the comments, for example, then this means you have normalized your data. The main concept is again this. the program need not be aware of the internal structure of the data. And usually when you have a program that accesses JSON, JSON is actually the structure of the data. So you do not query the data in a general way. This is like we are moving back 50 years ago. Of course, all data models have their place, both the navigation, the hierarchical, the JSON data structure, taking it as an example of a hierarchical data structure, and the relational one. But the relational one, you have to acknowledge that it existed for 50 years and still existing and ruling pretty much the world of databases. So, and the term relation that it's using is actually in its mathematical sense. So, what he says in the paper is that given a few sets like S1, S2, S3, Si, and Sn, which are not necessarily distinct, then R is a relation of these n sets if you have in this relation the first element from S1, the second element from S2, and so on. So Sj is the jth domain of R. R is said to have a degree of n if it has n sets. Today we less use the term relation, we just call it a table. The word, it's interesting to know that the word table actually does not appear anywhere in the original paper of codes. Normalization in the paper from the 1970, it just means that you don't put any non-simple domain into simple ones. So you don't put the actual children in the columns and in the values of the actual blog post. You only have plain, simple values. You just have the values. But you do have the foreign keys. The children of the relation do reference their parent. There is no actual mentioning of queries in Edgar Code's paper. He does mention that there could be a possible general structured query language that you could use in order to query this data generally. To sum up, before the relational model of databases, there existed two main models, and the relational model was actually a very revolutionary concept. The problem with the prior models was that they were very coupled with the actual implementation. The implementation of a tree, the implementation of a hierarchical store, or the implementation of navigation. And actually, there were some speeches by the proponents of these data structures that called programmers as navigators. Then Code arrived and he said that it's not proper to have this very specific and very coupled structure of data in hierarchical and the navigational model, because then you find yourself messing and trying to identify where is the structure. You need a more general and a more abstract way to access data, and then he presented it in the relational model. I think we have a lot to uncover in his additional papers, and I think the next interesting topic could be to see the roots of the null in databases and in the relational model, to see what code has said about the null, whether it's a value or whether it's not a value. How is what is the relationship in between null in databases and null in programming languages? Is it the same concepts? What are the pitfalls with null? So I will see you in the next episode, and I hope it would be the one that will discuss about null in SQL. I think it's going to be very interesting.